This is the Algebra 1 Unit 1 test review. We'll start with problem 1. Write a statement that could be represented by p to the power of 2 minus 2p. So simply we can write a number squared minus the number doubled. Number 2 asks us to write an expression that correctly represents 10 more than the cube of the product of p and q. So I'm going to start over here. I'm going to underline the things that I find important. I'm going to go the product of p and q. That's one thing, so I'm going to put parentheses around it when I write it out. And then I'm going to cube the product, and then I'm going to 10 more than the product. So right here we've got cubed, we've got multiplication, we've got addition. Now I'm going to go ahead and write that out, and I know I've got 10 more than the product of p times q cubed. So that product is cubed, not p or q, but the whole product itself is cubed. And I have 10 more than that. Number 3 asks us to write an expression that correctly represents the quotient of the square root of y and 10. So what this is asking us is the quotient of the square root of y and 10, which is the square root of y divided by 10. So we're using division, which is represented by the quotient, and we're going to use the square root of y represented. We know square root is one of our words to know. So I'm going to have the square root of y divided by 10, or the square root of y divided by 10, or the square root of y divided by 10. Number 4 asks us to write an expression that correctly represents the absolute value of the difference of a number cubed and 5. So that means we've got our absolute value side, and then inside of our absolute value we're going to have the difference of a number cubed. So that gives us x cubed, and the difference of x cubed and 5 means we're subtracting 5 from x cubed, and we're going to end our absolute value. We're taking the absolute value of the whole thing. Number 5 asks us to write 3 different verbal expressions that correctly represent the following algebraic expression. That algebraic expression says 3x minus 7. So we could write this out 3 different ways. One way would be 3 times a number minus 7. Another way could be the difference between triple a number and 7. And another way could be 7 less than triple a number. Number 6 says, if 45 children sign up to ride the bus and each bus carries X number of children, write an expression that could be used to determine the number of vehicles needed for the trip. Well, if we go ahead and say y is going to be the number of vehicles needed for the trip, then we will have y equals 45 children divided by the number of children each bus carries. We'll solve for the number of buses needed. So we got 45 divided by x will give us the number of buses we need. For number 7, we're substituting and simplifying. So what we need to do here is go ahead and use parentheses when we substitute like we've been taught to. So I'm going to go ahead and rewrite this, substituting in p equals 2 and q equals -7. So I've got 3 times 2 minus 2 times -7 all over 2 times -7, which is equal to, now we can simplify each part. 2 times 3 is 6. So we got 6 minus 2 times -7 gives us -14, because a positive times a negative is a negative, all divided by -14, which is, again, 2 times -7. A positive times a negative is a negative. Then we can use keep, change, change. So we'll keep the 6 positive, change the minus sign to a plus sign, and change the negative sign to a positive sign. And then we know that we've got 6 plus 14, which gives us 20 all over -14, which we then can simplify to -10 over 7. Then we'll go to our second page of the test, where we'll start off again using simplification, where we'll go ahead and we'll substitute in our numbers first. So we'll have 2 times the cubed root of 27 minus the square root of 48. Sorry about that. I think actually that the q should be equal to 49 and that we've had a small typo here. So we're going to write q equals 49. We'll go ahead and add that in here. Q equals 49. And then we'll go ahead and simplify our cubed root and our square root first. We know for our cubed root, we're looking for a number multiplied by itself twice that equals 27. So we'll start with the number 1 and we'll count our way up. And we know that 1 times 1 times 1 equals 1. 2 times 2 times 2, well, 2 times 2 equals 4, times 2 again equals 8, so that's not it. 3 times 3 equals 9, times 3 again, that equals 27, so we know then the cubed root of 27 is 3, so we'll go ahead and put that over here. We know we've got 2 times 3 minus, then we're looking for the square root of 49. So this is just a number times itself. Well, we've already gone up to 3, and we said 3 times 3 equals 9. So then 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. But 7 times 7 is 49. So I think the square root of 49 that we're looking for here is 7. And this is going to give us then 6 minus 7, which gives us a final answer of -1. In number 9, if the area of a triangle can be determined by evaluating the expression of 1/2 BH, where B is the base and H is the height of the triangle, what is the area of the triangle with a base of 6 inches and a height of 8 inches? So what we're going to do here is we're going to go ahead and rewrite out our given formula for the area of a triangle. We got 1/2 base times height, and then we're given here that the base B equals 6 and that our height H equals 8. So we can plug all that into the equation and we get 1/2, use our parentheses, 6 times 8. Well, 1/2 of 6 is going to give us 3, right? Because that's the same as dividing 6 by 2. So if we divide 6 by 2, we get the number 3. And then we're going to multiply the number 3 by 8. And 8 times 3 gives us 24. Match each statement with the corresponding property. All right. If we have 5 plus -5 equals 0, we know in addition if something equals 0, if we add two things together and they equal 0, that those two things are inverse. So this would be the additive inverse property. So we scan down here looking for that property, and we find G is the additive inverse property. So we'll go ahead and write G in right here. In the next part, we've got 5 times the product of x minus 2y. And I believe what has happened here is we've gone ahead and distributed the 5 here, and then we've distributed the 5 there. So we've got 5 times x, and then we multiplied that 5 times 2y to get 10y. So now we have 5x minus 10y. So that looks to me like the distributive property. So I'm going to go down here. When I look, I find number D is the distributive property, and I write in the distributive property. For 4 times 0, well, that looks like anything times 0 equals 0, and we call that the multiplicative property of 0. So I come down here looking for the multiplicative property of 0. I find that it's k. I'm going to write k in up here. And then I go to the next one. Alrighty. We look at the next one, and we're looking at it, we see a grouping, right? We've got 6 times x times y. And then in the next section, we've changed the grouping. So now we've got 6x times y. So what happens if we change a grouping? It means we're using the associative property. We're making little social groups using this associative property. So we've changed our social groups by moving the parentheses around the x and the y to put the parentheses around the 6 and the x. So this is the associative property of multiplication because we're using multiplication in the problem. So I'm going to go over here. I'm going to look for the associative property of multiplication. And we find that it's h. And we can come over here and write h. And now on to the next one. 9 plus x equals x plus 9. We're using addition, and we're using the commutative property because we simply commuted the x and the 9. So we come over here, we look, oh, here we go. C is the commutative property of addition. So we can write in C real quick and move on to the next one. 7 times 1/7, or 1 divided by 7, equals 1. Whenever we have something multiplied by something else that equals 1, we should right away recognize that we're using the inverse property. Also, we know that 7 times 1/7 is the inverse of 7, so 7 times its inverse is going to be equal to 1. So we can come over here, we know we're using the inverse property of multiplication. We look down here, and we find the multiplicative inverse property is E. So we can go ahead and write E in right here. Now we've got -3 times 1 equals -3. To me, if I've got a -3 on one side, and then the whole problem equals -3, and I'm multiplying by the number 1, right away I should recognize, well, this side is identical to this side, which must mean I'm using the identity property of multiplication. So look, we're looking through and we see the multiplicative identity property, number L, letter L. We can write letter L in here. Next problem. We got 4 plus the sum of x and y, and then we have the sum of 4 and x plus y. Oh, that looks to me like we're just changing our groupings again, except this time we're using addition rather than multiplication like we did up here. So we've got the addition going down here using grouping, so we know it's the associative property of addition. So let's look for the associative property of addition, letter B. Come down here, we've got 6x minus 4y equals 2 times the product of 3, or times the sum of 3x minus 2y. Well, it simply looks like to me is that we've gone in here and we've distributed the 2 to the 3x, and we've distributed the 2 to the 2y, and we've pulled it over here and simplified, so 2 times 3x equals 6x. We carry over our minus sign, and then 2 times 2y equals 4y. So that simply looks to me like the distributive property again. So we come up, we look for the distributive property, letter D, we come back over, we've got the distributive property. And for this last one here, we see 3 plus 0 equals 3. Right away we know this because it's 3 on this side equals 3 on this side. We have another identity property. Since we're adding it together, adding 3 plus 0, it must be the addition identity property. We see that's letter A up here. We can go ahead and just write in letter A. And then move on. Number 11, the real Slim Shady wrote these steps when solving an equation. 12x minus 2 equals 14 minus 2. Step 1, 12x minus 24 equals 14 minus 2. 12x minus 24 equals 12. 12x equals 36, and x equals 3. What is the property that justifies step number 1? We look over here, and we see 12x minus 24 equals 14 minus 2. What we've simply done is gone from this first part right here. We've distributed 12 to x. We've distributed 12 to 2. So I'm going to say we've used the distributive property. Now we're finally on the last page. Problem number 12. Ask us if 5n equals 10, what property of equality justifies writing p plus 5n equals 3p plus 7, as p plus 10 equals 3p plus 7. What we've done here is we've simply substituted 5n equals 10, right? So we're given p plus 5n. So then down at the next step, we substituted 10n for 5n. This is called the substitution property of equality, or the transitive property of equality, whichever you prefer. I apologize, actually. I think this is actually the reflexive property, because what we've done is we said 5n equals 10, and then we've just re-plugged back in 10 for 5n, so this is the reflexive property of equality. The next part is to evaluate each expression. You may earn additional points for showing all of your work. So in this first part, we've got -2 times the absolute value of g minus j. So we'll plug in g first. We've got 7 minus j is 9 plus 5. We can simplify the inside, and we know that 7 minus 9 equals -2. So then we've got -2 times the absolute value of -2, then plus 5. We know that the absolute value of -2 is actually just 2. So then we know that we've got -2 times 2 plus 5, which equals -4 plus 5, which equals 1. For the next step, we've got j plus 2g, all divided by g times j. So we go through here, we've got j, which is 1/6, plus 2g, which is 2 times 1/3, all divided by g times j, which is going to be 1/3 times 1/6. We'll go ahead and we'll start simplifying. That leaves us with 1/6 plus 2 times 1/3 gives us 2 divided by 3, or 2/3. And then multiplying 1/3 and 1/6 together, we multiply the tops together to get 1 divided by the bottoms multiplied together, which is 3 times 6, to give us 18. And then we know that this is actually saying the same thing as 1/6 divided by 1/18 plus 2/3 divided by 1/18. And if we've got something divided like this, that always means we can go ahead and multiply it up to the top. And so then we get 18 times 1/6 plus 18 times 2/3. 18 times 1/6 is the same as 18 divided by 6, which equals 3. And then we've got 18 divided by 3, which equals 6. And then we've got 6 times 2. So this is going to be the same as saying 6 times 2 is 12. So then we've got 3 plus 12, which equals 15. Otherwise, we could have multiplied our 18 by 2 first and gone 18 times 2, which would have been, put this whole thing over here at 36 divided by 3, which is also equal to 12. In this next part, we have 7 minus g to the power of j. So we'll go ahead and substitute all that in. We've got 7 minus g is equal to 12 to the third power. And then all that's minus 31. And then we've got all of this divided by negative j, which is equal to 3. So we can go ahead and simplify. We know that 7 minus 12 is equal to negative 5. And we've got that to the third power minus 31 all over negative 3. So when we multiply this out, or when we use our cubed power, we know that we've got negative 5 to the power of 3, which is the same as saying negative 5 times negative 5 times negative 5. Well, we know that a negative times a negative is going to be a positive. So we got the first two negative 5s, which we can write out down here, negative 5 times negative 5. That's going to be equal to 25. And then we still have another negative 25 to multiply by. So we'll go ahead and say we've done all that. And then we're going to multiply this again by negative 5. And then negative times a positive is equal to a negative. So we have a negative answer. And 5 times 25 equals 125. So we've got negative 125 minus 31, all divided by negative 3. Well, a negative number minus a number is the same as a negative number plus a negative number. That goes along with keep, change, change. And so now we're adding two negative numbers, which means we get an even larger negative number. So then we got 125 plus 31 equals 156. So we got negative 156 divided by negative 3. We know that just like a negative times a negative is a positive, a negative divided by a negative is also a positive. So now we've got 156 divided by 3. And then all we have to do is divide. So we know that 3 goes into 156, I think a total of 52 times. For 16, we have the square root of a plus b cubed. So we come down here, we can plug in a. So we have the square root of 144 plus negative 3 cubed. Just like we did negative 5 cubed, we know that the cube of a negative number is going to be a negative number. So we have 3 times 3 is 9, times 3 is 27. So we can go ahead and say we know we're going to at least have negative 27 over here from this negative 3 cubed. And we know we're adding that to whatever the square root of 144 is. And so what we did earlier was we were counting up through the numbers to see what, on page 2, to see what 49 was. The square root of 49 was. So now we're going to continue counting. And we said the square root of 49 was 7, so we know this has to be greater than 7. So we'll go ahead and start at 8. So we have 8 times 8 equals 64. And 9 times 9 equals 81. 10 times 10 equals 100. 11 times 11 equals 121. And 12 times 12 equals 144. So we know the square root of 144 then must be equal to 12. Now we have 12 plus -7, or the same as 12 minus 27, is equal to -15. And now for the final problem of the review, we've got x, which is equal to 3, times the cubed root of y, where y is 64, and that whole thing cubed. So we're going to go ahead and plug that in. We've got our x, which is equal to 3, times the cubed root of y, which is 64, and that whole thing squared. Well, earlier when we were doing our cubed roots, we started with 1, and then we went to 2, and then we went to 3, and we said the cubed root of 27 was 3, because 3 times 3 times 3 was 27. So now if we go to 4, we got 4 times 4 is 16, times 4 again is 64. So if 4 cubed is equal to 64, then the cube root of 64 is equal to 4. So then this is going to give us 3 times 4 squared. And 3 times 4, of course, is equal to 12. So now we've got 12 squared. And just like in the problem before us, where we said the square root of 144 was 12, so 12 squared will equal 144.